Find the Boolean function q in terms of a comma b. So here a b is some NAND gate. Again a is given for the NAND gate for a and a. Again b and b is given for this NAND gate. These two are, so this is the circuit diagram, that is a combination logic. So we need to find out the q. So here ab whole bar you get in this NAND gate. The simplified format you have to find out. Here AA is nothing but A. Finally you get A bar, because this is A and A is A only, its complement is A bar. So this is B and B, this is B for AND gate, NAND gate it will be B bar. So A bar and B bar is here, you get A bar B bar whole bar. So for this AND gate we are getting AB whole bar and A bar B bar whole bar. For this you have to take whole bar because it is an AND gate. So this will be, you can write this as AB whole bar, this is A bar whole bar plus B bar whole bar, this is A plus B, this is whole bar. And if you apply this one, for example, this will become AB plus A plus B whole bar. This is AB plus A bar B bar. This is what we get. So this is again multiplied, that is AB plus A bar B bar into AB plus A bar B bar is this only. This whole complement becomes, this is exclusive NOR, this will become exclusive OR, the complement. So A bar B plus A B bar. So this is same as A B bar plus A bar B. So this is option D. Option D is the right option. Figure shown x2, x1, x0 will be is complement of A2, A1, A0 if y is equal to 0, option A, option B y is equal to 1, option C y is equal to A0 is equal to A1 is equal to A2, option D y is equal to A0 bar is equal to A1 bar is equal to A2 bar. So here all are exclusive OR gates. So we need to find out, that means x0 should be complement of A0, x1 should be complement of A1, x2 should be complement of A2. So that means if the other input is exclusive OR gate is a odd function, if one input is 0 for example, the output is depends on other input. That means, so if it is 0, output will be 0, if it is 1, output will be 1. If one input is 1 for the exclusive OR gate, the output is the complement of input. If it is A0 value 0, output will be 1. If A0 value 1, output is 0. That is a functionality of exclusive OR gate. That means if you maintain a constant input, the second input as 1, the output is equal to complement. That means x0 can be complemented when y is equal to 1. x0, that is A0 is equal to complement x0. That is what? x1 complement of A1, x2 complement of A2. So only when y is equal to 1. So option B is the right option. Process PI in two-process solution of critical section problem is as follows. Flag of I and flag of j was initially false, both are boolean, and turn value is int, integer value. Do flag of I is equal to true, while flag of j, the turn value, if turn value is j, then flag of I is equal to false. And then while turn is equal to j, do nothing, flag of I is equal to true. In the enters into critical section, then turn is j and flag of I is equal to false, and remainder section while true. So here enters into critical section, next turn is j, flag of I is equal to false, remainder section. Which one of the following statement is correct? Statement A, it will violate the mutual exclusion. Statement B, it will satisfy mutual exclusion but fails to satisfy progress. Option C, it will satisfy both mutual exclusion and progress requirement. Option D, none of these. Actually, this is the structure of a process in a Decker's algorithm. The Decker's algorithm will satisfy all the three requirements of critical section problem, that is mutual exclusion, progress, and bounded waiting. So this is the structure of process PI in a two-process solution. Flag of I is equal to true means process PI wants to enter into critical section. At that time, it is checking to see whether flag of j value true or not. That means process Pj also trying. Then it will check the turn value. If flag of j, turn value j both are true, for example, then it will make the flag of I value false. So that process Pi not at all try to enter into the critical section. So it will solve the problem of busy waiting also. So there is no chance for the Pi to go into critical section while Pj is already in the critical section. It will strictly satisfy the mutual exclusion, because while Pi come out of the critical section or Pj comes out of critical section, they will make the turn value respectively, and the flag of j value will be false when Pj comes out. So that there is no chance for the two processes to be reside in a critical section Pi and Pj at the same time. It will perfectly satisfy the mutual exclusion. Coming to the progress, for example, the critical section is free and no process is entered in the critical section so far, but process Pi and Pj wants to go into the critical section. At that time, both will make flag of I value true here, and the process Pj will make flag of j value true. So when simultaneously at time t0, if it makes true, at time t1, if process Pj makes a true value, by checking that respective turn values, the respective flag values will be made as false, so that there won't be any difficulty. Only one process based on the turn value will go into critical section without waiting continuously, without going to the loop. So that progress also will be satisfied. So it will satisfy the both mutual exclusion and progress requirement. Option C is the right option. For doing analysis and design is SDLC, B is prototyping, C is SS-AD, T is none of this. So for analysis and design to do, SDLC, option A, SDLC is the software development life cycle. So that is the phases, different phases in a development of software will be represented. But prototyping is also one of the model for developing software using prototyping model. And then SSAD, structured system analysis and design. Structured system analysis and design will be used for analysis and design model. So option C is the right option here.